thought this topic would be interesting for you. And you'll see how it's make easy this GSR for your work to be done in an efficient way and the easiest way. We are talking about NIO.2. NIO.2, it's introduced in JDK 7. And in JDK 8, there is going to be some enhancement and additional services and options in the GSR. There's no more development as a maintenance releases. So we are going to talk about the JDK 7. This GSR is 203. There's a standard GSR. Okay, let's introduce myself in a fast way. I'm working at a company based in Egypt. It's eFinance. It's all the major of the projects targeting the government and all the building a payment hub and automating all the payment income and outcome for the government from tax, customs, pension, subsidy systems, and so on. Working with banks for easing of the payments in different banks and integration all over the country. I'm one of the board of Oracle Egypt Architect Club, responsible for sometimes you have customers in Egypt and EMEA have to build a solution based on Oracle applications. So you have to tell them what is the correct way and reference architecture to integrate the product, or if they are going to do some hands-on or in-house development, you usually help them that there is another libraries you can do and rely on. There is a technology you can do, putting the reference architecture for the product. I'm GCP. I'm especially involved in Adobe GSR program and Adobe JDK. I'm adopting WebSockets API, JSONP, JSON processing, and JAX-RS. This is my main adoption around playing with another GSRs. I'm Blogger consultant, blah, blah, blah. But initially I focused on working in Java since 2000. This is my slogan. I feel in working with Java like coding architecture, not just doing some lines to do out with my code. Okay, let's see our agenda. Our agenda here, we are going to talk about 8 topics. Okay, we will not cover all the 8 topics. It will be divided in 2 sessions. This session will cover essential part of the to get you introduced how to work with NIO. What is the concepts? Is essential to everyone to work with NIO. Then the other 4 topics is advanced one, from networking, synchronous calling, traversing, watching services area, and introductions. These you are using in certain cases. But for the majority of us, we work with the essential stuff. Essential stuff we are covering is working with the plus class, and we will get introduced what is a plus class, and working with metadata, which is not covered well in previously defined I/O. For Linux fan or Mac, Linux, such operating systems, and there is not good introduction before for symbolic and hard links, and we are going to see how to manage those. And the new file API, this is the brand new class, final class, contain a lot of methods that ease of reading, writing, buffered, unbuffered, streaming, directories, blah, 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 as we will see. And when we get to pointer. Then we will talk about random file, which is already exists before, okay, but there is a major improvement done in this release. Other advanced stuff that we will cover tomorrow, the traversal process using FileVisitor API, which is make easy. It's a standard now. You don't have to use third-party libraries from Apache IO or something like this. You have the standard and implement it in your JDK in an efficient way. Another one is monitoring, which is, it's interesting for me because I'm working in integrations. I need to monitor for specific files, which files especially if you need to search for specific files with search criteria or moving the files based on real-time monitoring. Just you get the file, you get notification, and do your process on this file. This is done, all of this is done with watching service API. Networking and socket-based, how it's improved in JDK 7 because networking and sockets was introduced from JDK 1. And the most jewel of the crown, as they say, is asynchronous channel, which affect the majority of Glassfish implementations, okay, is this one. And it's good benefit from, I think if you're attending before this session, the session for concurrent APIs, concurrency. This is the pool mechanism and handling of the pool of blah blah of the threads introduced based on the concurrency API introduced in JDK 7. This is our agenda. We will cover these 4. Actually 5, but I'm not covering. This is essential part, not just. Before we dive in, okay, why we need to move to Java 7, JDK, NIO. Many methods didn't throw exceptions. When you do delete, copy, paste, or something like this, and file doesn't exist, you don't get exception. You will find a process stop. Okay, I need to introduce a message, meaningful message to the customer. This you have problem in the permissions or blah blah blah. You don't have these in previous versions, and it's improved. The rename method didn't work consistently across platform. If it works, sometimes it works fine on Microsoft platform, but it doesn't on Unix or some implementation of Linux. There is no real support for symbolic links. You can't create shortcuts by the meaning of shortcuts or hard links. Okay, more support for metadata. You don't have only what is the size of the file, what are the is it hidden or not, or blah blah like this. What if you are working on POSIX, Linux, Mac, different class or different platform have different view of properties, defined properties, which is different from platform to platform. It gets introduced, and this JDK has a part of metadata. Accessing file metadata was inefficient, actually, yes. Many of the file doesn't scale. You know the problem when you're requesting large directory listing over the network. Maybe your application is stuck and hanging because the memory is full. Sometimes when you're making a large directory traversing, blah, 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 and a lot of entries, you get service denial, your application is down. Now it's implemented efficiently with watching and file traversal API. Okay, it was not possible to write reliable code that could be recursively file tree respond to appropriately if there was a consensus symbolic link. The main problem with the symbolic link is circular linking. When folder A or file or folder pointing to folder B, and we have a link pointing to A, recursive operation, which infinite loop. It doesn't implement it well previously, and you have to use it third party. Now it's implemented efficiently because when you tell the API, I don't want to follow the links, it doesn't follow, just it can detect this is a symbolic link, okay, skip it, and go to the sibling folder till the end of the traversing of the folders. Okay, let's talk about POS class. The POS class is the milestone of NIO. Any operation involved in NIO2 should have in its method parameter POS class. No file class, no more file, POS. What is the POS class? The POS class, where does it reside? Think of the POS class as a pointer to the file or directory in file system. What is the file system? It's a driver that contains your files, okay, managed in directories. This is the link, this is the file, and this is the address of the data. Mapping between the file and the data. You know that the file structure is on hard disk on FAT, like FAT or NTFS or journal on Mac or something like this. It's mapped between the link to the file. Where is the file? This file is based on content from address A to B. Okay? Not cross drivers. On drive C, I have a class from address 100 blah 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 in memory until this. This is the hard drive. And there is a map pointing the FAT table till this file that is called test Java, pointing to its content from this address to this address. This is the management. This one, the first is the key. This is the POS, pointing to the data. This is the POS, okay? So the POS resides in file system. fat, NTFS, or blah blah blah. So you need to get the file system and tell him, please give me this address of the path, the directory or file link, symbolic link or others. Okay, it allows us to work with files and directory as well. So the file system can be accessed through the file system's final class. So you can get the default file system and get the path. It returns you to the path and you can play with it. What is the file name, blah, blah, and so on. Okay, I will show you the code that how you can get the path. Okay, and it will be more easy. Something like this. Creating a path is so simple. Just path class. There is a final class called POSIX.get. This is can anyone tell me this is absolute or relative? Right, because it starts with this one, this slash. By the way, the path class is modular class. What does it mean? If you remove this slash and put this one, it takes care of the platform and the characters internally. There is no problem. I can write it on Windows. I can write it like this, and it works. Even on Mac or Linux, I can work it like Windows passes. Not with C, because Mac and the OS doesn't know the drive. There is a root drive, and the Windows only have the CD and blah blah. Okay, there is no problem. This is scaling. It's modular one. You can get from string of arrays, because the get method is var_arg_array, variable argument array, which is string variable argument. You can construct string from commas as a string. So you can pass a string array, or you can divide it. What the benefit of dividing? You can construct passes from passes in memory without worrying to rename. And you have the base class, and you need to work with this base class with different files. But you need to change this base class will affect all of them. You can do it. It's another modularity. And you can get it from URL, from file, and you will see that. Take care that I told you before that I need to get the path from the file system first. So the get method is shorthand for this file systems, the get default, the get path, the path. You can do this or this, but just shorthand. Okay, the path class has support to operations. What they are? Syntactic operation. What does it mean by syntactic operations? It's normal. By the way, syntactic operation means operation on the passes in the memory, not actual files. Like constructing, converting class pass from pass, till you find your final syntax and real types. Then you call the operation, please create this file, please read this file, please check this file. So all the pass operation is in memory. You can give it a pass, as you give me the parent, give me the your name, give me the structure of your hard drive. What is your file system? This is all in memory operations. Doesn't actually affect or calling the internal operating system. Okay, so in almost any operation that involve manipulating passes in memory, okay, without accessing the file actually, it's called syntactic operation, and the pass class do it for you, as it's shown in the code. Like what? Like creating a pass, retrieving information about the pass. It's relative, it's absolute, is it file, directory. It's just information. Removing redundancies if you have ... and constructing with, like, you know that ... is a parent, and you have redundancies. You can call methods resolve. It remove all the redundancies from the pass. Converting a pass, I need to convert it to a file, to a URI, to absolute pass, to real pass, to blah, 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 conversion from file to anything else. And joining two passes. Conversion can help us where? If you are writing legacy systems using File API, there is improvement in the File API that introduced before. There is a method called toPass that convert the file to pass. Okay, then you can write your code using the NIO2 without rewriting your application from scratch. Joining two buses, if I have multiple buses, then I need to finally construct the file from the base class, and I will get the parent, get blah blah blah, and convert it. So you can joining two buses and get sub-bus directories, a lot of methods that you put. Is the bus start with something, end with something. All majority of checking that you do with get string and check this is the end of string. And instead of that, it have a bunch of methods that help you in detecting and getting the sub-buses. And a lot of comparing buses is the two buses have the same records, and so on. Operations over the file, referenced by buses. What does it mean? That is, you have now a bus, and you're pointing to a file, and then you need to create this file. You need to read this file. You need to create a directory, actually, on the hard drive. So the second one is involving, which is covered by the files final class that we will point out in point number 4. Those are the operations. Do you remember this? This is the normal way that we're writing the files, okay? So to convert it from scratch, you write this. This is the bus you can get, and so on, you can work. This is a file, by the way. You can call a final class that create file and process this bus, and the file will be created. 2 lines. You don't need file output stream and passing the stream, or file writer and append the data and blah blah blah, and writing a lot of lumping codes. Okay, moreover, starting with JDK said in post classes, the post classes are available, as I told you before, that you can convert between the two buses. In the past, you can tell them to file and will return to a file object, and the file you can call to bus and get you the bus plus. How it is? Something like this. This is a bus. Okay. If I need to convert it to string, just pass to string. It gives you the string representation of the file. If you need to URI for network operation or something like this, you can call to URI. An absolute path, you can get the absolute path. A real path, which is C, blah, 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 all the paths. Okay, you can get the real path without following the links. And finally, you can convert it back to the file. That's all about the path class, which is the basic. All the involved operation that we will work with it, okay, will contain the path. Let's talk about the essential stuff, which is the second part introduced is metadata. Who knows what is metadata?
Permissions.
Information?
About information size.
Who created this file and so on.
Do you know when I told you on JDBC, get the metadata of the database? What does it mean? It does mean the structure of the tables, not the data itself. It's data about data. But regarding the construction or the properties that doesn't involve in the content, like the size, the owner, is it hidden, is information, is it directory, is it file, who is owning, who is the group involved in it, all of this, or metadata. It's not related to the content actually. Okay. Sometimes you have questions about files such as whether directory or where is it hidden, or what is the size, who owns the file. Actually direct yourself to using metadata, especially if you're working cross-platform, okay, and you want to write application that run on Mac, run on Unix, run on Linux, and Windows as well, okay. Think of metadata, that support of majorities of this platform. We will see how it supports.
I'm sorry, may I ask you a question?
Yes?
So it seems like path can refer to more than one file. But when you are calling to file,
the path refers to one file.
More than one file.
One file.
One?
One.
But
you can construct it. The
yeah.
construction is different. You can construct it from different passes. But finally you point to one point, directory or file or network stream or whatever. Just one pass.
Okay, understood.
Okay. Metadata, information, and then you get Anthony to manage the metadata. NIO.2 introduced this metadata in attribute package. Okay. Since different file systems, as I told you before, have different views because you know the schema of working in POSIX or Unix, that R, W, that 8 of permissions that you write in file doesn't include in Windows. Windows have views, another view like DOS views or some sort of ACL for security. But in Unix and Linux have groups and users, different properties for each platform. Okay, this maintained in terms of views. Each operating system have different view, and each view contain an implementation of methods doesn't include it in another views. It depends on the platform. And you have the methods that you can ask for this specific file. It doesn't this path supports this view. If it's okay, you can work on it. If not, think of your application working Linux and Windows. So you can work with POSIX on that platforms, and when you going to work on Mac, you should do this check. Oh, sorry, in Windows. Okay, we will see it. We have 6 views by default implemented at JDK. The basic is all the operating system support the basics. It's include from 7 to 8 methods that cover all the common functionalities. It's hidden, it's the size, it's the directory file link or symbolic link or the common basics. So all the other views extend this view, okay? And we have a DOS and Samba views. This is working Windows only. POSIX that work in Unix and Unix-like operating systems. And the file owner, which is responsible for setting and getting the owner of the file. It works in both. Any operating system supporting setting the owner or getting the owners, it can work with the file owner view. It's specific for security. Okay, file access list, its control, it's depend on the hierarchy of and the attributes of the file. It's not just setting the owner for just I'm the owner of the file, setting the user as the owner, different attributes. Okay, you have permission to read or write. Read and write, or another permission you can define. You can use the access list, and it's famous on Windows. And this is the most interesting part of user-defined attributes, and actually I'm using it, I started using it in my integration part with files. I give you a case. I have integration from system to systems, okay, especially the external systems. And I put some encryption codes, algorithms, and the source of the sender of the file, and blah, 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 all the information relative to know who is the sender, and the information about the sender, and the encryption algorithm, and blah, blah, blah. Before that, I using NIO.2, I was putting all of this in the header of the file, inside the content, and Git parsing, and it's readable for everyone. So what to do is make it securely to use this API as an attribute attached to the file as a metadata. So when you open the file, you will not find all this information. I am and the implementer only who know about this. So you can. Yes, if it supports, it defined. If it's not, you use the normal operating. But I tried in Mac, I tried in Unix, and I tried in Windows. It works. So you have to ask first.
It won't work on file. It works on the GFS.
Yes. When I talk about Windows, I'm talking about the two platforms, FAT and the NTFS, and the different file systems. Those are all the views. This is the metadata. There is a huge implementation that make it easy to use and manage metadata. At the final, I try to show you some code at the final because the time is tight. The demo will be at the final. Symbolic and hard link. Does anyone work with hard link? which cases you find to use hard links? You would like to reference. There is a difference between the two. Okay. For sure, Linux and Unix users, especially administrators, for making backups and something like this, familiar so much with concept of hard links, especially the Mac OS time machine working with hard links. And I'll tell you after a while what is the difference and what the mechanism of the working. For sure, one of them, it's me, that working with Windows, not shortcuts. So no, you don't do shortcut. You're just pointing to a file in different drive or different place, network or blah blah blah. That's sort of shortcut. Think of the link is you have a map, different aliases for the same file. It's normal link. There's a difference between hard and symbolic, and we will get introduced to this. But think of the link normally, it's just pointing aliases for the same file. Okay, you have a map, the names X, Y, Z, all of them pointing to the same file. Each method of the pass class know how to detect link. You have methods to ask, is it symbolic link? It's hard link, so you can do your operation. Especially when you're traversing a tree and you don't need to follow the link. Okay, you just, if you detect this as directory, symbolic link, or don't follow. Just skip and get the actual directory and the traversal till you reach your point. There are two types of links. Hard links and symbolic links, and this example will get you familiar with. This is the folder. This folder contains a file1, and the file1, okay, do you remember that the file is just an address for the content on the hard disk? Think of this as the content of the file1, and this is just the name, the pointer, okay, that reference the first and the end of the data. I'm going to create a symbolic link. Okay, what's the representation on the operating system? This symbolic link, it will be creating file, whatever the alias you give, X file or test file, not file1, test file. Okay, the symbolic link at this time refer to what? Refer to this path. Okay, you always, when you create a symbolic link, you will find the size of the symbolic link is the number of characters that containing the name of the file. If the file is 8 characters, you will find the size of the symbolic link is 8 characters. What if about this 1 giga? It doesn't relevant to the content, just pointing to the file. So when you delete this file, it doesn't work. There is no pointer. On the other side, okay, this is your hard link you created. Hard link directly pointing to the content on the hard disk. What does it mean? It doesn't mean if I'm deleting this, the content still exists because there's a pointer. Think of this as you have an object and different instances. Okay, the garbage collector cannot, this is just an example, cannot release the object till there is references. Think of this like this. You have a reference, so it's very efficient in the backup because the backup just containing the data and comparing which data less or more and replacing this with the time of the access. And as he told me that he using the maybe sometimes you're making a repository copy of some sort of hard links with different aliases. Okay, so if by mistake your project is going to delete it, you can revert it back from the other side. But the main content, not just the file pointing to the your applications. You have the content again, just a copy, but with different aliases. The different navigation, a lot of navigation till you find your path. Light shortcut, but referring to the content rather than the file address itself. It's clear, or all of them? All of you are coming from lunch, and I know you are feeling to sleep. I don't have my lunch. So, it's clear, or something little bit mistakes? It's fine? Okay, thank you. All of this blah blah blah. The difference between hard link and symbolic link. The first one tell you that you can create hard links created only for the file. Can anyone tell me why? Not for directory like symbolic link. Symbolic link relevant for both, right? Yes, because the directory doesn't have a content. Second thing, hard links cannot exist across file systems. Why? So I can point from C to a file on a D. No, you can't. Why? As you told me, because it's relating to the content, and the content is managed at NTFS or FAT file at specific folder. Drive file system. So it can't cross. You can point from C to a file on D or C as a hard link. Shortcut, no problem. It's just pointing to the address of the file, not the content actually. The target of hard link must exist, because I need the content to refer to. Okay, but for symbolic link, you may refer to network drive that doesn't actually exist as a content, just a name. Okay, file with zero content, and you need to shortcut to this, no problem. Removing the original file that your hard link point to does not actually remove the hard link content. For sure, because it's point to the content, vice versa is the symbolic link. When you delete the symbolic link or the original file, the symbolic link doesn't work because there is no reference to the original file or directory. If you remove the hard link or symbolic link itself, for sure, the original file doesn't impact. Hard link, this is for security issues and attribute. You have to put in mind that the hard link behave regularly as the same file, because if you apply a security attribute or any other modification, it gets affected on the file, the hard link itself, but not the same like symbolic. Symbolic pointing to the metadata of the file, not the actual content. If you have here defined attributes, you'll not find the symbolic link itself as a link. Hard link look likes and they behave like regular files because it's pointing to the content, and symbolic link target may not even exist, therefore it's more flexible to do shortcuts. That's about symbolic. Bunch of methods that support symbolic and creation, detection, and behavior when using the standard API. This is the most interesting one, which is now, as we know about POSIX, memory operations, and I'm deciding to create the file. I'm deciding to create the link, the hard link, the symbolic link, to delete, to copy, to move, to do so, to list directories, to create temporary directories. How can I do this? It's all about file and directories. As we have to know this, we need to do this normal operation and more and more. NIO.2 encapsulate all of them for you in a class file, final class file called files. This class is the major and milestone for all the operations to create files, even its normal files, buffered file, channel files, streaming files, whatever, and directory and temporary files and directories as well. And copying, moving, and a lot of checkings about operation on the file. But now we are going to actually working on the file. This is the operation over the file that we talked about on past class operations. So what's new? The file provide a file operation like reading, writing, creating, and opening file in different behavior perspective from different streams, buffered and unbuffered, normal text files, and a lot of these mechanisms. And also, you can work with a well-known delete copy move operation in efficient way, and if you don't have a permission, you will get the message told you don't have permission on the file doesn't exist. You get normally very good message to show you to your customer, and nowhere is the problem, not like before. And you will find work methods for buffered and unbuffered streams. Okay, and we will cover this tomorrow, especially on networking, asynchronous, and anything related to networking should be working for buffers. Anything related to channels work with buffers. Directory operations. Now you can list in one line. You can give the file, you give the pass, list this directory. It will return you array list of passes, iterator, and you give the list of the traversal. Not level 1 traversal. Okay, level 1. So you enter the directory on the sibling, only that return. What about the recursing? We will cover tomorrow in FileVisitor API, so you can do a recursive operations at your hand. Reading, creating, and you will find also a list how you find system routes, creating directory with create directory, create temp directory. Create temp directory has a great improvement when creating directory and when the deletion is become. Say for example you have a system and involved a lot of copying from file to file to managing and doing like Photoshop. Photoshop, one of the major files that create temporary files for cutting from image and putting in the layer and getting the data back, and all of this file created. And if you maintain it, you will find after a while your hard disk is full. Okay, and you have a lot of crowded by temporary files. So you have the option, delete it yourself. This is the normal way, and just hooking the JVM and told them, please, when you shut down my application shut down, delete all of these temporary files from your side, or when you exit the try resource, when you're opening the stream and just exit the stream in the try resource, or you close, you tell them just register this temporary file and delete them. So you have three options, your own, or hooking with the JVM, or at the try resource level. These all of them, creating temporary file or folders. You have this option. Fine, I'll be with you. Some definitions. What is a stream? The stream is anything or destination. It can be anything from disk to memory, or stream or everything. Streams support different kind of data like string, bytes, primitive data type, localized characters, and something like this. Do you know what is the difference between buffer and buffer? In simple way, without all of this, let's consider this example. If the buffer is portion of the memory, if you have all of us know the computer architecture, okay, processor and the memory, who's fastest? The processor for sure, and the memory is the second fastest place to work with different devices. So you have operation on the data, and you need to move this data to the memory, so it's consumed to another devices, files, network, graphics, blah blah blah. Okay, processor in gig speed, memory in meg speed. That you have like source of tab like this, and putting data from tab like this, bottleneck. So what to do? Just improve the cache. What is the cache type of memory? Static memory. That is speed. That's more speed than the memory, but less than the processor. So processor can talk to this memory portion, which is the cache, putting the data. Okay, and when it's full, just the memory get the data back, and he is full flush. This is the portion. This is the buffer that and it's in size. In K. In our cases is in K. You have buffer 1K, 2K, 3K, depend on your operations, okay? In memory size, it's in K because it's too expensive as an implementation. So if you have a file operation without buffering, when you read or write every character operating system, you have the operating system have called many times for every single character read or written. So if you have 100 character, you have 100 call. What about the buffer? If you have 100K of the buffer, you have one call from the file, put in the memory, one call from the operating system, give these 100 characters. Did you see the reduction of the calling, which is mean performance? Buffers are considered to work with channels, which will be covered in networking, and the channel API that you can create from the file system. Idea that you can get from the files in Java is you can check, there are a lot of methods that you can check with. Is it file readable before I can write on it? It's writable, executable, regular file, or hidden. Just pass to them the path you have, and you can get the answer, and you do your operation before deleting, before copying, before traversing, before returning. This check enables you to, for sure, kind of file directory you are dealing with before applying any operation such as writing and reading. This is the final summary. Let's define in terms of complexity what you can do with files in terms of complexity. From the far left is more far left. You can see. I know I didn't say. This is less complexity, and on the far right, okay, is more complexity. So you have methods. This is methods already exist. You can. This is one method. Read all bytes. You give it a stream or image. It will get you a byte array in one call. Fine. Files.read all bytes or read all lines. Oh, a lot of time to read the lines. Just normal text file contains some lines. I'm doing reader input stream, give it the file, and then input reader for character and local. Then iterate while loop, then finalize and give me the output. In one line, just files.read line, give the path of the file, it will return me array list of string. This is common used for small files. What if I'm scaled? Or I need to work with local or buffers. Okay, you have a new buffered reader and you pass it to the buffer you have created. It's an array of buffers. You pass and the pass and you get the data till you finish at the bytes. Reader and writer for text files and local operations specifically for large files. Large files working with buffers. No more solution instead of buffers. So the network working with buffer because you're receiving packets and data. Streaming working with buffers and blah blah blah. Asynchronous working with buffers. For your input stream, if you have any input stream, any stream like socket or something like this, you can deal with this. This is stream for unbuffered also data, okay, and used with existing API, which is like file input stream and file output stream and all of this existing streaming APIs. And you have channel. Think, channel. Oh, channel mean I'm working with data back and forth in memory, which is I should use buffers. Like random access file works with channels. For channels, by buffers, and file channel will be used for advanced features like file looking, mapping, getting portion of the data in the memory and look it and working on it, and release it back, okay, to your file without maintaining the concurrency on the file. And memory mapped I/O. Okay, all of this working with asynchronous and networking and random access files. That's all about directory and files. Finally, final thing is the power of how many one works with random access files actually. Random access files. Is it strange term or no problem? Okay. Is it powerful? Let's see how it's powerful. An advantage of using non-sequential, which is random. What does it mean by random? If you have sequential file means to get byte after byte, get this first byte or first line, second line. What if I'm here and get this You need to jump like this. You can't use it with normal file. You should use it with random access file. Random access file, in summary, can manipulate and locate specific byte at any location and manipulate it and replace it or delete it, like your word processing document. Think of word processing and what I said before about buffering. Your word processing, all operations are in memory. If you forget to save it, you will lose everything, right? Because it's buffered. You write in buffers, and when you click save, you flush your buffer to the hard disk. Content is permitted random access to their content and known as a random access file, which is RAF. With RAF, you can open file seeking particular location and read from right to that file. After you open the RAF file, you can read from or write to it in random manner using channel, and we will see a relationship between the operations. This is a normal sequential reading line by line, or in random file I can jump to any location without any restrictions. Okay, what the benefits? Not using sequential file, I can build up word processing files or seeking particular location, search in the content, getting specific data from the file. For sure, sequential data is more flexible and easy to create than RAF, that's more or less flexible. RAF allow you to read single character, chunk of bytes, it's a buffer, lines, replace portion of the file, append lines, delete lines, and so forth, and allow you to perform all these actions in random manner. Technically, if you would like to know this, from NIO.2, a brand new interface, okay, called seekable byte interface. Seekable byte means I'm seeking for bytes, okay. Channel means buffers, so what is the relation? You will see. And introduced in channels API. It's extend byte channel. Okay, what is the purpose of byte channel? Byte channel actually introduced in JDK 1.4. Okay, and byte channel is just buffering and manipulating the character, the bytes. Okay, so it extended by seekable byte channel. So now I'm able to do the operation on bytes. And also, it Java7 improves the file channel class by implementing this interface and providing RAF file channel by the mean. File channel now in Java7 implementing seekable file channel. What does it mean? Oh, I can seek a memory, a byte of locations, and the channel allow me to work in memory for buffer, so I can read and look and making mapping for the memory for the content. By this is the mechanism for map memory I/O and something like this. Okay, I can use this. For bytes seeking, I can use byte channel. So mixing of them, okay, you have taking byte channels with reference to what? To a buffer. What's another improvement is done on this file is the file channel. This is the access. Provide facilities such as mapping region of the file directory into memory for faster access, locking region, and reading and writing bytes from absolute location without affecting the channel itself. Closing or opening another channel for reading. Just open, I can deal with the bytes. At the same time, I finalize my operations and close the session or save the data. Seekable byte channel interface is based on the old interfaces, readable. Seekable byte channel also implement this and this. What does it mean? Now you have the option to work asynchronous in the same way, full duplex. Before you can't work, you have to read, okay, finish reading, then you have to write. Now it's full duplex, like WebSockets. The same way, read and write at the same time. There is no problem. So, indeed, thank you for this relationship that get for us such a powerful mechanism. Essential topics are finished. Questions? Okay, thank you for attending for sure. This is my contact for reference. Yes. No, let me show you in just a minute. This is like file and directory integration from the code. I'll share with you this code. This is actually Java 1 code. If you need to copy just a file, you do this. File.copy. It's fine. From bus to bus.
How can I write unit test for this code?
Using this API?
But how can you test? Cause is copy. Copy is static method, so you
Okay.
can copy.
Why? You need to multiply. You can call it from unit testing.
For example, we need to make situations that we throw exception when we find how we involve
Why you need to modify? You are mocking the something when you're working with another developer that doesn't finalize your API, so you need to finalize your testing. So you make a mocking of this file to complete your test. This is the standard API and implemented, so you can use it directly and maintain your. You are using copy inside methods. You are implemented. And you need to test strong methods, exceptions, so you can use it in the exceptions at the end test. You don't have to mock the copy because it's already implemented. I told you to copy, just do it. It's not already, it doesn't exist, it exists, it's not interfaces, it's actual implementation. So you don't have to mock it. You just mock it. Why you won't? Are you going to test the copy method of the Java standard? Okay. Because it's final message. What's the problem? You need to bytecode hacks, you need to test the bytecode that you have or something like this. You have the option to go to underline, to under your code. You have the option to get down to your API and get the stream and test your results. So you can test the results as you get this pass and you can check the two passes already, the copy is done by the passes. It's a passes actually, you understand? Just you call this in your test, in your program. Just you have to pass two passes. You need to copy this and this is the result. And after the testing, you need to check that this copy is the same as the copy, the source that you copied to. Just taking testing of two passes, your actual destination from the source.